Hello everyone, this is Rekha Kotwal. Today we will see some core concept of database management system. In previous video we have seen the difference between data and information. So basically now we are aware about the data as raw collection of facts and figures. From this data we can get the useful information, or you can say the information is the transformed version of your data. So this data and information both are the basic concepts of DBMS. DBMS stands for Database Management System. Basically, this DBMS is the system software that is used for creating, organizing, and managing the database. It provides an environment for the user to perform various operations onto the database, like creating data, inserting data, deletion of the data, updation of the data, and data retrieval. So all these operations we can perform with the help of DBMS. Now, this information is the systematic and meaningful form of the data, knowledge acquired through the study and experience. So that is nothing but our information. For example, the address is shown here. This address is the collection of data. Various type of data is there. Number form data is there. Text form data is there, and it makes the useful information. Now, what is database? See, database is just like a central repository where your data is being stored, right? Or you can say that it is an organized collection of related information so that that information can be easily accessed and managed by the users. For example, dictionary. Generally, we use dictionary. In that dictionary we are having the word meanings, so data about the data is there, related data we get from the dictionary, right? Various applications are there, like library management system, in airline database, in railway timetable, in student database. Everywhere various types of information is stored in at a single place, so that is called as database. Now, what are the components of database system? The very first component is user. We are the users, or the people who interact with the database. That is first component of the database system. The user can be application programmer who can develop the application. End users like us, end user just use the database application. Data administrator. Data administrator is the person who manages all the activities over the database. So these are the types of users. Then software. The software is a layer that lies between stored data and the users. Or you can say it is an interface between your data and the users. For example, this database system, DBMS. DBMS is the software that allows user to interact with the database. Now, hardware is the core component of database management system. Hardware are nothing but your physical devices like computers, hard drives, cables and all. And the very important component is data. Data is the core component of your database management system. Data can be in the form of numbers, characters, pictures, videos, audios, everything that can be stored electronically. That is called as data. Now we'll quickly see what are the advantages of this DBMS. DBMS has some advantages over traditional file processing system. Number one is controlling data redundancy. Data redundancy is nothing but the repeated data is avoided in database management system. So data is recorded only in one place so that repetition of the same data is avoided in the database, and no duplicate data is found in database management system, so that it will not waste your memory. Another advantage is data consistency. Data consistency means data item appears only once and it's getting updated value immediately available to all users. So consistency means the correct relevant data is stored in your database at one place. Now control over concurrency. Concurrency is nothing but at the same time you can perform various operations. In a computer file-based system, updating one may override the values recorded by the users. Whereas in this DBMS system, we can concurrently access the various data, various documents with the help of this DBMS system. Now, automatic backup and recovery system is provided by the database management system. For example, suddenly you got the power failure, then automatic backup and recovery is there for the database management system. So data loss is very minimum in DBMS system. Then data independence is there. Independence means separation of data structure from one layer to another layer, like from application program that is hidden from the actual users. So this is called as data dependency. Now, what are the applications of DBMS? Where this database management system is applicable nowadays? If you see around you, almost everywhere this database management system is used. For example, in airline and railways, online databases are there for the reservations and displaying the schedule of the information. User can book a ticket anytime. So this is because of the database management system. Now in banking sector, customer can inquire, can open the account, can open the loan accounts. Every transaction can be done with the help of this database management system. Now in education sector, we can see online registration is there, online form filling is there, student information is stored at one place. So this is nothing but the database management system. Now e-commerce, nowadays we are using various online apps like Amazon, Flipkart and all. So this is your e-commerce. Business activity is controlled by this database management system. So everything is done with the help of this database system. Human resources, HR department is also using this database management system for storing information about the employees, their salaries, their taxes, benefits, generating salary checks. Everything is done with the help of database system. So these are some applications of DBMS. Now we will see the very important concept of database management system, that is data abstraction. Before going to this concept, you must know what is abstraction. See, abstraction is nothing but hiding of something, right? Or just showing the necessary details. So this data abstraction is done in DBMS for ease of user interaction with the database. This data abstraction hides irrelevant, unwanted details from the user to avoid the unnecessary complexity. So the data that is not useful for the user, that data or that information is hidden from the user. So this is called as data abstraction. The main purpose of data abstraction is to achieve data independence to save time. What is data independence? We will see shortly. Let me give an example of data abstraction. I'm giving you very simple example, right? If you go to the toy shop, right? So you just ask for the particular toy, and you just check for the price, right? If that particular toy is in your budget, you buy it. So, irrespective of where that toy is manufactured, who is the manufacturer of that toy, right? How many labors are involved in the manufacturing? All these data, we are not concerned about this data, right? So, all this information is hidden from the user. This is unwanted information, and that is hidden from the user. This is known as data abstraction. One more example, it's very simple example. See, if we want to access any email from Gmail, then we don't know where the data is physically stored. That means we are not aware about where the Gmail server is located, whether it is in India or USA, or what data models are used to store the data, how data is transmitted from one place to another place. We are not concerned about, we are not care about it, right? So all this information is hidden from the user. So hiding unwanted data is called as data abstraction. And why this information is hidden from the user? To make the system more easier for the user. So unnecessary complexity is avoided with the help of this data abstraction. Now see, in data abstraction there are major three levels. At the bottom you can see database is there, where your all the data is stored at the centrally. Then how this database is managed, right? The very basic or bottom level is physical level. This physical level is also known as internal level. Then after that conceptual level is there. Conceptual level is also called as logical level. And at the top you can see the user level. This user level is also known as view level. So we are the users, we all are at this user level. So what is happening at this logical level and physical level, we are not concerned about it. We simply don't know what is happening there. We just get the data from the database. Yes, we fire the query, we write the information, and we get the data from the database. So it's very simple. For example, we all are using Google, right? So we are the users, we are at topmost level, user level, right? In my computer system, I just go to the Google's browser, and I'll just write the query and whatever information I want. For example, topmost engineering colleges in Pune, so I'm writing that in Google. So Google will get that information from its database and will display it to you, right? So that information is there in the database, right? From database the information is retrieved and then it is provided to you. But during this stage, right, physical level is involved, conceptual level is involved, but user is not aware about all these levels. So this is known as data abstraction. So basically, there are three levels of data abstraction. Physical level, it is the lowest level. It describes how data is actually stored in the database. Whether your data is stored in the bits or bytes format. So all this information is kept hidden from the user because this physical level is very complex. User cannot understand it. So unnecessary data is hidden from the user at this physical level. Now comes logical level. So it is the middle level. We can see here logical level is also known as conceptual level. It is the middle level. This level describes what the data is stored in the database, right? Physical level gives you how data is stored, and logical level gives you what the data is to be stored in the database and what is the relationship among the data, that is given by the logical level. See, these two levels has its own schema, its own structure. That structure is also hidden from the user. And now the topmost level is view level. This level is also known as user level. This is the highest level of the data abstraction. This level describes how user interact with the database system. We are the users. We all are at this view level. So user view data in the form of rows and columns or tables that is stored in your database. We will see how data is stored in the database. There are various data models. So table and relation. What is relation and table? We will see that in our next video. The user can only view the data and interact with the database. So rest of the information is hidden from the user. And this is the purpose of data abstraction. Let us assume that we are storing customer information in customer table. So at physical level, these records can be described as block of storage because physical level sees that how data is stored in the database, right? So what is the unit of data storage and how many bytes are there? So these details are hidden from the programmer. Now the upper level is logical level. For this example, the customer's record can be described as columns and attributes along with their data types. How many customers are there? What is the name of customer? What are the salaries of customer? What is the role of customer? So these are attributes. Logical level says that the schema or skeleton of the table is given by the logical level. Logical structure is given by the logical level. Now the uppermost level is view level. It is user level. User just interact with the system with the help of whatever GUI provided to the user, right? They are not aware about how data is stored and what data is stored in the database. So this is all about data abstraction. Now data abstraction gives the birth to one more concept, that is data independence. Now data independence is what? See, technically the ability to modify a schema definition in one level without affecting a schema definition in higher level is known as data independence. Now the question is that what is meant by schema? See, schema is nothing but the logical structure of the database. Or you can just say that schema is nothing but the skeleton of the database, raw skeleton of the database. Actual information is not there. In abstraction, we are having three levels: physical level, logical level, and user level, right? So how data is stored at physical level? There is particular schema, there is particular skeleton is given. How data will be stored? At logical level, the particular schema is there, logical structure is there. Both these levels are independent to each other, and that is called as data independence. See, in this example, if we see the diagram, physical level and conceptual level, every level has its own skeleton, own structure. Whatever changes done in the physical level, those changes will not affect the conceptual level, and vice versa. Whatever changes we made to the conceptual level, those changes will not affect to the higher level, and this is known as data independence. Or you can say that data present at every level is independent on another level. Now we have two types of data independence. One is logical data independence and another is physical data independence. Logical data independence is the ability to modify conceptual schema or logical structure without causing application programs to be rewritten. That means whatever changes you done with the logical level, those changes will not affect to the user level. The change will be absorbed by the mapping between external and conceptual levels. Usually it is done when logical structure of database is altered or updated. Now, second type of data independence is physical data independence. Technically, the ability to modify internal schema without having to change the conceptual or external schemas. Now, whatever changes made at the physical level structure, those changes will not affect to the logical level. The modification at this level are usually to improve the performance of the system. Thank you. This is all about data abstraction. You can subscribe to my channel Study Vista for more tutorials about CS and IT. Thank you very much.